Namaskar. We are going to test three different types of water today, and we will test these waters for ORP, which is oxidation reduction potential. Reduction potential reading, if it is high, that means it is good water. It is having more oxygen in the water, and it will kill all the dead tissues and all that which is not required in the drinking water. Second thing, we will test the pH of the water with this chemical. If the pH of the water is 7, that means it's a neutral and pure water to drink. If it is less than 7, it is acidic water. If it is more than 7, it is alkaline water. Sometimes it is good to drink alkaline water also, people say that. And third thing, we will test the TDS of the water with this instrument. TDS is the total dissolved solids, which says that how much is the total impurities are dissolved in the water. Not all things which are dissolved in the water is bad. So many minerals and all this one is required for our body. So is very less TDS water is also not good. Very high TDS water is also not good. In between, people say this one 200, 300 TDS of water is fine. Even 100 to 300 TDS of the water, people say it is fine. So now here, this is our tap water which is coming from the borewell. This is filtered water, that is RO filtered water, and this is boiled water. This is RO filtered and then boiled water. Okay, so now what we have done, in these 6 test tubes we had taken around 5 ml of the water in these. So these 2 test tubes had that Borewell water, means tap water. These 2 test tubes had our filtered water, and these 2 test tubes had the RO filtered and the boiled water. So what we did, so this is our solution to test that positive ORP and negative ORP. If you see this one, this is the indication here that if the water doesn't change color, it is a positive ORP, and if the water changes color to pink and all that, it is negative ORP. As per the instruction here, it says that if color changes to pink, indicates negative ORP. If color remains same, it is positive ORP, and positive ORP is good. That's what it says, this one. And here it says this one, different colors are indicated for the 3, 4, 5, 6 pH. This is like acidic water. 7 is green, which is neutral water, and alkaline is kind of a blue. 8, 9, 10. This is the pH scale for this water. So after that, we had put 2 drops of these in all borewell water and this filtered water and this boiled water, and then 2 drops of this pH solution we had put in tap water, filtered water and boiled water. So now you see this one, this was kept for some time. If you see this one, this is not completely like water, like watercolor. That means water is colorless. It's turned little whitish, though it was mentioned here pinkish, but I am not sure. It is turned a little whitish. Okay, that means it has changed color. And here also in this filtered water also has changed color. It is not same as the water was colorless, so it is also changed color to whitish. So we have to further explore that one, what it means for the whitish color, because as per the instruction given on this bottle, it only talks about either it will not change color or it will change color to pink. Probably what we can do, that we can try to put 2 drops extra to see this one, or 1 drop extra first to see what happens. Let's put 1 drop extra, or let's say 2 drops extra. Let's see what happens. Okay, before putting 2 drops on this, I will show you, this is our boiled water. And boiled water, if you see that, it is also like little bit of change color, but less as compared to So this is in this hand I am having boiled water, and this is having our this one filtered water, but I had put 2 drops more on this one, so this is not put 2 drops more. So but it is still not fully colorless, so let us put some 2 drops more onto this one, and let's see what happens. Oh, we have put more actually. Okay, so wait for some time, let's see what happens. We will shake it a bit and let us see what happens. I am not sure whether putting more of this thing will cause something. Okay, so in fact earlier when this was earlier, before putting extra drops, it was having color was not changed much. So is compared to all these tap water and that filtered water, this was good to drink, because this was showing at least very less change in the color, very less change. Now we have put the 2 drops of this pH solution into these waters. This is our tap water, and this is our filtered water, and this is our boiled water. So if you see this one, this color is a little bluish kind of a color, little bluish kind of a color. So if I match it with this one, see, if you match it with this one, it matches with like 8 pH. So I can say this one, this tap water is of 8 pH. Now this is filtered water, this is a little yellowish color, so this will match with this one. If you see this one, see, this is matching with this one, so this is kind of a 6 pH. Now this is a boiled water. Boiled water, if you see this one, this is kind of matching with our 7 green color. So that means tap water is having 7 pH, which is good to drink. Sorry, boiled water. This boiled water, right? Boiled water is having our 7 pH, means boiled water is good to drink. Now this is our TDS meter. Now we will measure the TDS of the water. So this was our tap water. So tap water, see the TDS reading. Focus on this one reading. So tap water reading, if you see this one, it shows around 250. If you see this one, 250, 258. This is the reading for our tap water. Now this is RO filtered water. See, RO filtered water reading has gone down drastically. It's become the 19. So that means RO has taken out most of the dissolved minerals or whatever out from the water, which is not good. And this is our boiled water, which is also 19, means after boiling the TDS of the water is not changed, but drinking a very less TDS water is also not good. See this, so if we drink, see what happens, they say this one, the reading keeps changing, because the way we immerse it, the way we put it, actually the reading keeps changing. So we have to take 3 readings and take average of it. That's what they say, this one in the instruction sheet. So it's around somewhere, let's say 1820, and this is also around 1820. So means after boiling RO water, the TDS is not changed, but RO has drastically dropped the TDS from 250 to 20. So that means we have to increase the TDS for the RO filtered water. We have to do change in the setting of the RO filter so that it doesn't filter out all the minerals of the water. Okay, so after that, when we are seeing this one, that after doing the boiling of the RO filtered water, it's not changing the TDS. That means we can drink the boiled water, but we have to repeat the experiment again. When we increase the TDS, let's say it's having 250, we have to increase the TDS to at least 150 or so that even after RO filtered water, it is having 100 to 150 TDS. Then we have to repeat the test again to see this one, if it is having any effect on the pH or this ORP, and then we have to further decide which is the good water to drink. But at the moment, the boiled water is good to drink because it's having pH as 7, and this ORP was, I think we have put more solution to it, more water, more solution to it. That's why all have become like whitish. So that we have to explore further. But earlier, when we had put only one drop, this had changed, exactly not changed color. Basically, it was a very minute change. So we can say this one, that it is having positive ORP. Both for the boiled water had positive ORP and boiled water has pH 7. So at the moment, boiled water is good to drink. धन्यवाद. धन्यवाद.